Hello, welcome to my channel. Let's start with junction diode as rectifier. So first of all, you should know what rectifier is. So it is an electronic device which converts AC power into DC power. So that's what rectifier is. Now we have two types of rectifiers. One is half wave rectifier and another is full wave rectifier. So as name suggests, half wave rectifier. It means it is a rectifier which rectifies only one half of each input AC cycle. That means one half could be rectified only. Other half is actually a wait for a half wave rectifier. In this case, we are using one AC supply. This is my AC supply, which is input AC supply for this circuit. We are using primary coil. This is my primary coil and this is my secondary coil. It is working as a step down transformer. So we have a step down transformer here connected to the junction diode and resistance. Across this resistance, we would be getting our input. So now, how it works? What is the operation for half wave rectifier? First of all, during the positive half cycle, this is a positive one because it is in upward direction. So this is a positive half cycle which is fed to this circuit. Now that means my A part will be a positive part during this positive half cycle and my B will be a negative part. That means P is connected to a positive one and N is connected to a negative one. Now when P is connected to a positive one and N is connected to a negative one, it is a forward bias as learned in the last lecture. So that means during this positive half cycle of input AC voltage, NA becomes positive and NB becomes negative. This makes the diode forward bias and hence it conducts current. That means for positive half it will be like this. The output will be like this. Now let us put the negative half cycle to this circuit. Now we'll be feeding this circuit with a negative cycle. This negative cycle will be fed to this circuit. Now whole direction will be changed. Now this will be negative, this will be positive. My A is negative and B is positive. That means my P is now connected to the negative and N is connected to the positive. That means this is reverse bias. So if reverse bias is there, that means there won't be any current during the negative half cycle. So this will be like a straight line. This is like a straight line. Now after this suppose we have another positive cycle. Again positive cycle is fed to this. This junction will work as a forward bias now. So if it is a forward bias, that means it conducts electricity. So we will get a output like this. So in this way, current flow through load RL always in the same direction. Hence DC output is obtained across this RL, and it may be noted here that output across the load is pulsating DC. It is in the form of pulsations. Now these pulsations in the output are further smoothened with the help of filter circuits. Now we can use the filter circuits to make it a direct one. We don't need the pulsations one. And this type is actually usually ignored because in this case lots of wastage of energy is there. Therefore it is not preferred at all, the half wave rectifier, because there is lot of wastage in this. Now, the next one is the full wave rectifier. So I will be discussing about it next. Now, we'll be learning about full wave rectifier. So in this case, we would be using two diodes here. Now in this case, we use a word full wave rectifier. That means we will get output for a positive as well as negative. In the last one, we didn't get any for negative one. So in this case, we will get for positive as well as for negative. Now let us consider that we are providing the circuit with a positive half cycle. So this part is being fed to this circuit. Now this part, let it be A and let it be B. So A will be a positive one and a B will be a negative one. So now in this case, P is in the D1. This be a diode 1 and this be a diode 2. So D1 is actually, it is connected with a positive one and the N is connected with a negative one. So that means D1 is a forward bias when we provide a positive voltage to the circuit. So in this case, D1 will conduct. And when D2 is there and we have a positive cycle, D2 won't conduct. Why? Because it is connected to a negative one, P is connected to a negative one, and N is connected to a positive one. Therefore, the correct direction will be like this. D1 is conducting and D2 is not conducting in the positive half cycle. So let us draw the AC output voltage. So we have fed a positive one. That means the result will as well a positive one. Now we would be feeding the circuit with the negative one, negative potential. So we would be feeding with the negative AC supply. So during the negative half cycle, now end A becomes negative and end B becomes positive. Now during negative half cycle, we have D1 as reverse bias and D2 as forward bias. So if D2 is forward bias now, that means D2 is conducting here. D2 is conducting and D1 isn't conducting during this. So therefore we have used two diodes here so that if one doesn't conduct, another one will conduct. So let me draw this again. So it is a negative one that we fed. This is the input and this is the output. Now we have another positive one. Now as you put again a positive, we will again have a positive cycle. Again this will be a negative one. Negative one will be fed. Again it will be a positive one. So this, as you can see, is a pulsating current again, and we can use this full wave rectifier to get a DC current, and this is very useful one as compared to the half wave, because in this case less energy is wasted. So therefore the full wave rectifier is more preferred one over half wave rectifier. So thank you for watching this video. I will continue with the different types of junction diode in the next lecture. Thank you for watching.